Hello, folks. My name is John Buchanan. I'm with the University of Tennessee Biosystems Engineering and Soil Science program. I'm pleased to present the Using Water Efficiently module from the Tennessee Smart Yards program. One of the overall goals of the Tennessee Smart Yards program is to protect and preserve the environment that we live in. A large part of that environment involves water. A primary concern is stormwater and how we as homeowners can affect the quality and quantity of stormwater that leaves our property during a rainfall event. Overall, the Tennessee Smart Yards program is built on 9 principles. Each of these principles is founded on how we can minimize the impact that our landscape has on the environment. So the focus of this presentation is how to reduce stormwater runoff from our property by capturing a portion of that rainfall through interception by plants and leaves, by infiltration into the soil, and by using barrels and cisterns to capture a portion of the rainfall. By reducing the volume of stormwater leaving our property, we reduce the movement of pollutants that stormwater could carry into local streams, and reduce the demand for municipal water by using rainwater for water uses that don't require potable water. In order to control stormwater in our landscape, we need to step back and look at the big picture. Where does water go? How does it move? Well, we see on this slide that we have plants, we have soil, and we have contours. And contours are just an indication of the ground slope. You can see in the lower part of the slide that we have a discharge going in the local stream. So in thinking about how the water is going to move across this site, we know that raindrops are going to fall and hit the roof, hit the driveway. Well, those surfaces are impermeable, so there's not going to be any infiltration. The water is going to have to move over to soil. If the soil is healthy, a large volume of that water will soak in. The plants, especially the trees that have leaves, they collect a lot of moisture just because they become wet. And so that volume of water does not become runoff. Another issue we need to pay attention to in our landscape is the steepness of our ground slope. And what's important about that for us is that the steepness of the slope is an indication of the velocity of the water when it runs off across our landscape. So it really becomes important for us to keep a steeper portion of our slope covered with vegetation so that we minimize soil erosion by slowing down the velocity of the water. When we think about natural landscape features, we also need to think about how they interact with a storm event. As mentioned, trees intercept rainwater, but equally important is that as raindrops fall through the leaves, those raindrops are slowed, so they don't impact the soil with the same velocity, reducing potential soil erosion and increasing infiltration. And the water that does infiltrate can then be taken up by the roots. Soil moisture moves by evapotranspiration through the plant and back out into the atmosphere. An additional advantage of the soil is that it not only holds water after it infiltrates it, but if we have contaminants like fertilizers or pesticides that are moving with the stormwater, natural processes in the soil can provide renovation, and those contaminants are not transported to a local stream. Now, as we've mentioned, trees intercept a lot of water, but let's put a number to it. As you can see on the slide, a deciduous medium-sized tree may take up greater than 350 gallons of water per year. Well, that doesn't sound like a lot of water in the big picture, but if we have a lot of trees, that can be a tremendous reduction in the volume of stormwater runoff, which also relates to a tremendous reduction in the transport of sediments and other pollutants to a local stream. Now, if we want the soil to soak up the water, it must be a healthy soil and not be compacted. A compacted soil does not allow for rapid infiltration. If we have a healthy soil that has a good stand of grass, we can anticipate that it might soak up or infiltrate 70 to 90% of a storm event, assuming that it's a relatively light storm event. If it's a very intense, if the water comes down very hard, very fast, then it's more difficult to infiltrate that volume of water at the same rate that it comes out of the sky. So, as we are here today, we are thinking about how we can use water efficiently in our landscape, and we need to incorporate both stormwater and municipal water into that equation. So what we placed on this slide is a plan that has 4 components for us to consider as we are inching our way toward having a Tennessee Smart Yard. The first one we're going to talk about is using a rain gauge to measure how much rainfall we've received so that we can determine whether we need to add more water to the plants in our landscape. A rain gauge is a simple device. You can pick these up in any home and garden center, and it's just simply measuring the depth of rain that we've received in our landscape. Now we have this notion, and it's a pretty strong notion, that plants do well if they get about an inch of water per week. An inch of water per week means that we got 1 inch of depth of water over an area. 1 inch of water over an area. So that's really a volume. Now we don't want to get too technical here, but that's really a volume of water, and what this rain gauge does is allow us to know the volume of water we receive over our area. So let me give you an example. 1 inch of rainfall over 1 acre of ground is 27,156 gallons of water. Let that sink in for a minute. 27,156 gallons is 1 inch of water over 1 acre. That is a lot of water. We may not own an acre, we may only own a fraction of an acre. But in thinking about the overall landscape we live in, when we're talking about stormwater volume, it can add up in a hurry. So when we look at this rain gauge, and by the way, this was a very progressive rain gauge. It measures in millimeters rather than inches. But if you're not bilingual, it's very easy to convert. There's 25.4 millimeters per inch. So you can see this particular rain gauge can hold about 2 inches of water. But by using a rain gauge, we know that if we get an inch of water per week, then we should not need to add additional water to our landscape. And so our plants should do well without having to add municipal water, because we were able to take advantage of rainwater to do this job. Okay, once again, looking at our plan. The second bullet is to use a rain barrel to catch rooftop runoff. So now we're thinking about, what if we don't get the inch of water per week and we need to add extra water? Well, if we don't want to use municipal water, then we need to be prepared to store rainwater. A very common way to do this is with a rain barrel. Now, this is not a new technology. Nearly 60 years ago, I was raised in a house that was 100 years old at that time. That house had a hand-dug cistern, and it collected the rainwater from the roof. That cistern was the source of drinking water for the original homeowners. So using a cistern is really a very old technology. All right, so let's bring this technology up to modern times. We really don't need it for drinking water, but we have other uses for the water. By collecting that water, we reduce the amount of runoff that leaves the property. Those uses may be to irrigate our landscape, to wash windows, cars, okay? One advantage, especially in Middle and East Tennessee, is that rainwater will not have the hardness. It will not have the calcium dissolved in it that our municipal water does. Therefore, as the surfaces that we wash dry, water spots will not be left behind, especially on the car after you wash it. And with all that good water, even Fido's going to smell a lot better. Fido looks pretty upset there, but he's going to smell a lot better when it's all said and done. But the main advantages is that we did not use municipal or potable water for this process, and we reduced the volume of runoff from our landscape. So let's think about how much water we could gather off a roof. Consider a 1,000 square foot roof. 1 inch of rain over that area is 623 gallons. If you captured, let's say 70 to 90% of that water, that would be 420 to 540 gallons. If you used 4 55-gallon barrels, you could capture 35% of that event. Now, if we're going to go with this methodology, if we're going to capture that water, we need to go ahead and use the water because we need that volume available in the barrel for the next time we have a rain event. In thinking about the components of a rain barrel, you obviously have a storage device, but we've got to get the water into it. We need to modify the downspout from the gutters to direct the water into the barrel. It must have a child-proof lid, and it's going to need leaf and bug-proof screens. There needs to be an overflow valve on that barrel. So when it fills up, the water will go out appropriately and not erode the soil around the barrel. It needs to have a spigot down on the bottom so that we can get water out. Now, remember, this water is only going to flow by gravity. So we will need to place the barrel a bit higher in elevation than where the water is ultimately going to go. And the last thing we may want to consider is some way to keep the mosquitoes from growing there. Now, as it turned out, this slide turned out to be a really good drawing, and I wanted to keep it in the presentation, even though the word mosquito is misspelled. In thinking about using rain barrels, let's say that we have an 800 square foot roof. If we had a barrel at each corner where the gutters discharged, then we could easily capture 450 gallons of water with a 1/2 inch rainfall event. So it is a significant source of water that could be used, like we said, for a bird bath, to wash your car with without having the calcium build up. So there are many potential uses of that water for events that do not require a potable water source. Okay, so question. Where do we go to get a barrel? Well, we can go to most any garden supply center. We can find architecturally significant looking barrels, and aren't they pretty? Okay. Certainly, the more fancy they are, the more they're going to cost. Now, for myself, I'm not really interested in paying a bunch of money for a barrel, especially when I can get one fairly cheap, and if I so choose, I can have it decorated. So as you can see on this slide, there are plenty of standard 55-gallon polyethylene barrels that come from the food industry. Many of our food ingredients are delivered to food production plants in food-grade barrels. And once those ingredients are used, these barrels are relatively cheap to purchase. You can take a barrel like this and you can install the plumbing yourself, and you can have it decorated as you wish. But it's important to remember we are not creating drinking water. We already have potable water available to us. There is going to be bacteria in the rain barrel. Not necessarily bad bacteria, but there's going to be bacteria there. Birds do what birds do, and that will be flushed off the roof with the rain event. Now, if bacteria is going to concern you, there is a simple solution. A cap full of bleach in a 55-gallon drum will eliminate the pathogen load. But again, this is not for drinking, and other considerations about the water quality could include about where the water is coming from. As shown in this slide, we have a cedar shake roof that may be treated with some type of algicide that may be undesirable to collect in a rain barrel. Okay. Another consideration is where are you going to place this barrel and how are you going to get water to get into it? Remember, these barrels are going to be heavy. If we have 55 gallons of water in there, it's going to weigh well over 400 pounds. So we need to consider that the soil under the barrel will get wet and may not be able to support the weight under saturated soil conditions. This could lead to the barrel tipping over. We also want to be conscious of the overflow from the barrel when it fills with water. If the barrel is right beside the house foundation, the overflow from the barrel may go down toward the footer and could affect the foundation of the home. So our overflow needs to be carried away from the foundation. The third part of our plan of itching our way toward using water efficiently is making sure that your irrigation system puts water where it will go into the soil. Now, assuming that you have an irrigation system, we want to adjust sprinkler heads to avoid spraying the driveway, the sidewalk, and other surfaces that cannot infiltrate water. As shown in this slide, we need to fix that spray head because it's shooting water straight up in the air. This would be an indication that the spray head has been decapitated by a lawnmower and needs to be fixed. As you see in this slide, we have a spray head that's putting water in the plant bed where the water will infiltrate and be available for the plants to use. This is an efficient use of that water. Going back to our plan. So the last component of our plan is thinking about the efficient use of water by our lawn. One way to consider the efficient use of water by our lawn is to allow the grass to grow with sufficient height so that it has enough energy to grow deep roots. Okay? So we don't want to mow. We do not want to mow the grass too deep. By giving the grass a couple inches of height, it can create deeper roots. Deeper roots result in drought-tolerant plants. As the soil dries out during the summer, it dries out from the top down, which means that there's probably water available throughout most of the summer in the soil, but it's at a deeper depth. If we allow those roots to grow longer, then they can tap into the deeper soil moisture and thrive for a longer portion of the growing season without having to irrigate. Again, we are maximizing the ability of the lawn to sustain itself by cutting it a little higher. And here are some recommendations for cutting height that are associated with the various grass species that are grown in Tennessee. Another good reference would be the folks at Lawn and Garden Centers who are familiar with the various species of grass that are grown in your location. An additional important point is to use sharp mower blades. As you can see in this picture, this grass has been torn rather than cut. You can see the brown ends and the shreds. That means you have an unhealthy plant that cannot produce the energy it needs to build a deep root system. So we need to keep that blade sharp, and we need to have good clean cuts that lets the plant heal after mowing and not lose a lot of extra water from the tissue. So as we think about inching our way toward having a Tennessee Smart Yard, we have looked at 4 planned components: using the rain gauge to help monitor our plant water needs, using rain barrels to store rain, and then using the rain water for tasks that don't require potable water, making sure our irrigation system is applying water efficiently and not spraying the driveway, and then mowing the grass a little higher to minimize the water use of the turf. All of these components work together to help us become an owner of a Tennessee Smart Yard. I hope you've enjoyed this presentation, and if you have any questions about what we talked about during this module, please don't hesitate to contact your local county agricultural extension agent and find out more about making your yard a Tennessee Smart Yard. Thank you very much for your participation.